All right, guys, so today we're getting out of parallelograms. And remember, we had parallelograms that broke into rectangles, a rhombus, and a square. Trapezoids are not parallelograms because they don't have two sets of parallel sides. They have one set of parallel sides, but it is still a quadrilateral. So a picture would sort of look like this. And we would have one parallel side here and one parallel side on the bottom. What those parallel sides are called are bases. So I'm going to draw another trapezoid. And remember that these are the parallel sides. The parallel sides are both bases. So maybe I have base 1 and base 2. The other two sides of our trapezoid that are not the bases are called the legs. So I have a leg over here and a leg over there. And then the last thing we want to talk about is the base angles. These are the angles down here. That's one base angle. Here's the other. However, if it were flipped up, the angles may be up here and here as well. So really, they're all base angles. So let's look at this problem here. We haven't learned any of the properties yet except for parallel sides, but that's all we need to find x in this trapezoid. If I extend the bases, I have two lines cut by a transversal, which makes 12x plus 3 and 13x plus 2 be same side interior angles. And guys, same side means supplementary. That means they have a sum of 180 degrees. So if we add these up, we can set it equal to 180 and we can solve for x. So I'm going to go ahead and add these up. 12x plus 13x would be 25x. 3 plus 2 would be 5. And that should equal 180. I can subtract 5 from both sides, and I get 25x equals 175. And then when I divide by 25 on both sides, you get x to equal 7. So remember that, guys, and the same thing would be true on the other sides. If I were talking about this angle and this angle, they're also supplementary. But you don't know that about these angles. That's what's different from parallelograms. So don't assume that those angles are supplementary. Now, there's a special segment in trapezoids called the median. It joins the midpoints of the legs of the trapezoid, and it's parallel to the bases. So if I draw my trapezoid, and I know that I have parallel lines here and here, if I found the exact center of both sides and connected those together, that would be the median. And it is also parallel. And that does something interesting. Since these points are midpoints, that means this segment and that segment are congruent, and these segments are also congruent. So we can find the length of the median using a formula, and it's pretty easy to find. We take one of the bases and add it to the other base, and we divide that by 2. So basically the median is the average of both bases. Let's look at the next. So we've got a trapezoid here with a median in it. So I'm going to mark a few things we know because it has a median. First, I know I have parallel lines. It's not going to be too important here. But I know the EA and DE are congruent, and CF and FB are congruent. And that might help me in a little bit. Okay, so hopefully that'll help me in just a second. I think it cut out for a second there. I'm going to go ahead and fill in AB is 25 and DC as 13. They want me to find EF, which is the median. So that one's fairly easy. I take the bases and I add them together and I divide them by 2. 13 plus 25 divided by 2 will give me the median's length of 19. And remember, it should be in between those two links. So if you get a number that's either smaller or bigger than either of the bases, that's not going to work. I'm going to erase those two numbers real quick because I don't want to get them confused with the next one. This one says that A to E is 11 and F to B is 8. And it wants me to find AD, this whole side, and CB, this whole side. Well, that one's pretty easy. I know DE is also 11 because of that midpoint that starts the median. So if I add those two together, I get AD to be 22. And the same thing applies on the other side. If FB is 8, so CF. And if I add those together, I get that BC is 16. So fairly easy on that one. I don't think leaving these will be any big deal, but I'm going to get rid of them anyway. Okay, now let's look at the next one. This one's a little bit tougher. It says A to B is 29, and it says E to F is 24. it wants me to find DC. Or I'm going to call that, actually instead of question mark, I'm going to call that B1, a base. So this is kind of backwards of what I was doing a second ago. I'm going to kind of come over here to the side to do this one. I know that if I add the two bases together and divide it by 2, it equals the median. So B1 plus 29 divided by 2 should equal 24. Now, we've worked problems like this before, and the first thing we want to do is clear the fraction by multiplying by the denominator. The denominators cancel over here. I get B1 plus 29. 24 times 2 is 48. Then I could subtract 29 from both sides, and I believe it gives me B1 would be 19. So DC is 19. So be careful on that one. Make sure you realize what it's giving you. A lot of people would just add 24 and 29 divided by 2 and not realize that 24 was the median. And the next one sort of does the same thing. It's a little bit more complicated, though, because it gives us expressions instead of numbers. So I'm going to fill the expressions that it tells me in very carefully. AB, 7y plus 6. It tells me that EF is 5y minus 3. And then it tells me that the top, or the other base, DC is y minus 2. So this is basically what we've been doing. It's just now we have variables running around. So I'm going to set this up. I have y minus 2 plus 7y plus 6 divided by 2. That's the sum of my two bases. And that should equal the median, 5y minus 3. Now, yeah, it's got variables in it, but it works the same way. We multiply both sides by the denominator. So those twos cancel. I'm going to clean this up a little bit. It looks like I have 8y plus 4. And on the other side, I'll distribute that 2. I get 10y minus 6. And now I can solve this for y pretty easy. I'm going to move the 8y to the other side with subtraction. So 4 equals 2y minus 6. I add 6 to the other side. So I get 10 equals 2y. Then obviously I divide by 2, and that gives me y equals 5. And that's probably one of the tougher ones. E, I'm not going to erase, or the last one I'm not going to erase because this deals with angles. It says EAB. So EAB is this whole angle right there at A is 63 degrees. It wants me to find angle DEF, which would be this angle right here. But remember, guys, we've got parallel lines, right? So these are corresponding angles, and corresponding angles are congruent. That makes DEF 63 degrees also. So not too bad, but watch out for that median stuff. Here's a trapezoid, and this is kind of weird because the bases are no longer the bottom and top. They're the left and the right. It looks like they want us to find the median x. So I'm going to take the bases, 24 plus 34, and I'm going to divide that by 2, and that should give me x. Looks like that would be 58 over 2, which equals 29. So pretty easy there too. So just to have these all together, this is a nicer picture, has exactly one set of parallel lines, and it has a median, which we can find. I'm going to put m equals 1/2 of the sum of the bases. Okay, or B1 plus B2 over 2. Now let's look at a special type of trapezoid. This is an isosceles trapezoid, and things are actually easier when we have an isosceles trapezoid. So it's still the trapezoidal shape. We still have our one set of parallel lines, but like an isosceles triangle, now we have one set of congruent sides. So the legs are congruent. So I've got this picture down here that says everything we need. I've got parallel sides. I've got a median, which again cuts those in half. And now I have congruent legs. So really, I know all of these are congruent, okay? It says the diagonals are also congruent. So this is congruent to that, and that helps us a little bit. And the base angles are congruent. So these two angles are congruent, and these two angles are congruent. So that's a lot of stuff to know. But it makes some of the problems pretty easy. So let's look at this isosceles trapezoid. It says decide whether each statement is true or false. I'm not sure where that came from. We're just going to solve. So first it says angle ADC is 54 degrees. It wants us to find the measure of angle BCD. Well, if I look up at my picture, I realize that base angles are congruent. So if ADC is 54, BDC is also 54 degrees. Let's look at the next one. It says the measure of angle BAD is 112 degrees. And then it wants us to find BCD, which is way down here. Now, we can do this a couple of different ways. You can realize that A and D are going to be same side interior angles, so they're supplementary. So I can take 180 and subtract 112. And when I do that, I get 68. So that means angle D down here is 68, and D and C are congruent because they're base angles, meaning that is also 68 degrees. Now we have one more here. This one says that the measure of angle ABC is 95 degrees. And it wants us to find the measure of angle ADC. So it wants this one down here. So it's basically the same thing. I can take 180, subtract the 95, and I get 85 should be angle C. And since angle D and C are congruent, that makes angle D 85 degrees also. Let's go and look at the left. If I look back here, sorry, I didn't mean to do that. I know that it tells me here the diagonals are quick. So we got two more problems here. It says done is an isosceles trapezoid. I'm going to go ahead and mark that right there. It says the measure of angle EDO is 110 degrees. It says the measure of DEN is 15x minus 5. It wants us to find x. Well, you should know same side interior angles are supplementary, so I can add these up and set it equal to 180 degrees. So 15x minus 5 plus the 110 should equal 180. That's really 15x plus 105 equals 180, which is 15x. When I subtract the 105, equals 75. And when I divide by 15, I get x equals 5. All right, last one. So it says we have another isosceles trapezoid. It says from P to R, so this whole diagonal here is 3x minus 7. It says that T to A, this whole diagonal here is 20. It wants us to find x. Congruent. Well, if the diagonals are congruent, then 3x minus 7 must equal 20, which means 3x equals 27. And when I divide both sides by 3, I get x equals 9. So guys, there's trapezoids for you. Of course, if you have any questions, we'll talk about them tomorrow in class. Good luck.